All right. Today we're going to work on lesson 3.2. It's really a blend of lessons 3.1 and 3.2, but we're really going to focus in today on using function notation and applying that to different situations, finding function values in a couple of different ways. All right. So function notation is when you're given an equation that represents a function. All right. We can write it in a form that's called function notation. All right. Now, an equation, let me keep going here. Function notation is a way of writing an equation in a special way so that we all know that the equation itself represents a function. So what happens is normally in an equation with inputs and outputs, we're going to have two variables like y and x. Okay, something like this: y equals 3x plus 5. In function notation, what we're going to do is replace the y with this. We call it f of x. All right. So y equals 3x plus 5 is the same thing as f of x equals 3x plus 5. This just identifies this as a function. Okay. So we know every input has a unique output, and we also can identify it by the letter here. So it can be f of x. They could call this thing g of x. They could call it h of x, whatever they want. And then we can identify it based on that letter that they put there. Okay. So that's function notation, is just writing it in this format. And again, this means that this equation represents a function. Every input has a unique output. Okay. Now, the x values in function notation represent domain or inputs. Okay. So when I put a number in here, it's the domain or the input. The f of x, the answer once I put the number in here, is the range or the outputs. Okay. So we're going to generate some function values using this function notation, and we're going to look at it also in a graph, which I have right here. So the directions say find the function values of these graphs. The graphs of the given functions are shown below. Find each indicated function value. So here's a graph. And what this graph represents, particularly in our case, won't really matter because we're going to use the graph itself to find functions values. Let me show you how. Let's say they wanted f of -1. Okay, the -1 is the x value that I want to find the y value that's paired with -1 when x is -1. So if we go up here to -1 and put a point at -1, okay, you can see that at -1, the line has a y value of 0 because the ordered pair here is -1, 0, input of -1, output of 0. So just using the graph, I know the function value at -1 is 0. Okay. What's the function value at 0? Well, when x is 0, y is -4. It's the ordered pair here where x is 0, 0, -4. Okay. So when x is an input, or excuse me, when 0 is the input, the output's -4. So 0, -4. How about f of 2? Well, what's the function value when x is 2? It's 2, 0. Okay. So the input of 2 has an output of 0. So the function value at f of 2 is 0. So we're just finding the location that represents the x value given, and then the y value that's with it, the ordered pair, is its output. Okay, so these are domains. -1, 0, and 2 are domains. 0, -4, 0 are range values. Let's do another one. All right, so they give us this. Now, remember, this is a function, right? It passes a vertical line test, and there's all these different inputs, output values that make up the points that make up the line, right? So they want f of -5. We're at -5. We're down here, right? The line represented is here. And at -5 for an input, the output's -4. Again, it's the ordered pair here. So when the input's -5, the output's -4. How about f of 1? Well, go to 1 on the x-axis, go till you hit the graph, and you're here. So f of 1 is going to be 2. How about the function value at 3? So go to 3 on the x-axis, go up till you hit the line. It's right here. That order pair is 3, 4. So an input of 3 has an output of 4. So we can actually find function values looking at graphs by looking at the ordered pair of the x value given. Okay, pretty straightforward. Okay, now we can also do function values using a table. Okay, so in this case, we got this g function. Again, remember I said they can name them different things. G of x equals 2x minus 4. That's the function rule, we call it. It wants us to complete the table. So notice here's my x column. All right, these are inputs or domain values. G of x are the answers when I use these x values in the g function. So we'll do it like this. So when x is -4, we're going to find g of -4. So I'm going to take this g function, 2x minus 4, and I'm going to replace the x with -4. And now I calculate this to find the answer. So 2 times -4 is -8. Now -8 minus 4 is really -8 plus -4. That's -12. So when you input -4, the output is -12. Do it for -1. You start all over again. So g of -1 means I'm going to replace the x in the g function with -1. That's going to give me -2 minus 4, which is -2 plus -4, -6. So when you input -1, your output is -6. G of 1, put 1 in place of the x. 2 times 1 minus 4, 2 minus 4, -2. So when you input 1, the output is -2. G of 2, take the original equation, put 2 in place of x. 4 minus 4, 0. So when the input into the g function is 2, the output is going to be 0. And then finish it up. G of 3, 2 times 3 minus 4, 6 minus 4 is 2. So when the input is 3, the output is 2. So that's how we can find function values using a table given a function. Okay. Now we'll look at some applications of this and see kind of where these function rules come from. So this one says that Ryan earns $41 a week working part-time at a bookstore. He makes $1 more for every book that he sells. The amount that he earns in dollars in a week if he sells B books is given by this function. So A, which stands for the amount of money he earns, of B, which is books sold, is going to equal the $41 he gets every week plus $1 times every book that he sells. So this is a function that tells you how much money he's going to make based on an input of the number of books that he sells. So that's a function right there. Okay. How much does he earn if he sells 18 books? Okay. Well, 18 books, B is books. So I'm going to find A of 18. The amount value when 18 books are sold is 41 plus 1 times 18. Obviously, 1 times 18 is 18. Add it up, you get 59. So the answer is he would earn $59 if he sells 18 books. Real straightforward, simple example of using function notation in a application question. Another one. Henry receives a $15 gift card from a photo center. He used it to buy prints that cost 5 cents each. So the remaining balance, B, in dollars on the card after buying X prints is given by this function. So remember, B represents the remaining balance. X is the number of prints that he buys. And obviously, we're going to take the $15 he has to start with and subtract 5 cents times every print he buys. Okay. So again, the answer to this will be the amount of money he has left on the card. Okay. What's the remaining balance if he buys 20 prints? So they're asking us to find B of 20, the balance when you have 20 prints. So it's going to be 15 minus 0.05 times 20. Okay. 0.05 times 20 is 1. 15 minus 1 is 14. Okay. So again, what did this represent? It represented how much money he has on the card after he buys these 20 prints. Okay. Another one here, and this was kind of unique. I want to get this one in here. So it's got a railroad crew and they lay 5 miles of track each day. They need to lay 145 miles of track. So they got to get that much done. The length, which is L in miles, that is left to lay after D days of work is given by this function. Okay, so this is the length of track they have yet to lay of the number of days they worked. So they have to lay 145 miles of this track and they do 5 a day. So if I take away 5 times every day they work, that will tell us how much is left after the number of days worked. Okay. The first question says, how many days is it going to take the crew to lay all the track? Now, this is a little unique here. So what we're trying to figure out is, when is the length of track remaining to be laid 0? right? How many days is it going to take to lay all the track? So that means at the end of the number of days worked, I want this to be a zero. So we want to solve this equation. Zero equals 145 minus 5D. Okay, when is there zero miles of track yet to be laid? So we'll add 5D. 5D equals 145. We'll divide each side by 5 and get D is 29. So it's going to take 29 days for them to lay all the track. How many miles of track does a crew have left to lay after 17 days? Okay, now they're saying you've worked 17 days. How many miles are left to do? So now we're going to find L of 17. Okay, the length of track left after 17 days of work is 145 minus 85. It's 60. So after 17 days of work, you're going to have 60 miles of track. So this is a good one to look at. You're going to get something like this today. You have to understand when you're inputting the value and when you're actually, going to set this equal to zero or a different value. Okay. All right. The last thing, or actually got two things you have to do. Sometimes they're going to ask you to evaluate functions that are higher ordered. Like it says linear, quadratic, and cubic. Okay. Linear means this kind of equation where x is to the first power. Quadratic means you have an x value to the second power in your equation. Cubic means you have an x power or an x variable, to the third power. It doesn't matter what this is. You're going to plug it in and solve it. So you have two functions, an f function and a g function. Okay, they're saying find f of -3. Well, use the f function. So f of -3 is going to be the f function with -3 in place of x. Now notice that I grouped the -3 because I'm going to square -3. So it's -3 times parentheses -3 squared minus 2. So the first thing we do here, order of operations, is square -3. So that's going to be -3 times -3 is +9. Now I got multiplication, subtraction. We'll do multiplication next. -27 minus 2, -29. So f of -3 is -29. Input a -3, output a -29. Okay, let's do f of 9. Well, f function. So f of 9 means replace the 9 in the equation, or excuse me, the x in the equation with 9. -3 times 9 squared minus 2, exponents first. -3 times 81 minus 2, multiplication. -243 minus 2. -243 plus -2 is -245. So an input of 9 into the f function gives us an output of -245. Okay. How about the g function now? So now they change it up and say, hey, do some work in the g function. Well, then we're going to work on the g function here. So g of 7, replace the x in the g function with 7. -3 times 7 plus 4, -21 plus 4, -17. So when you input 7 into the g function, we get an output of -17. How about inputting -4 in the g function? Well, we're going to write the g function with -4 in place of x. -3 times -4, +12, plus 4, 16. So an input of -4 gives us an output of 16. Okay, so there's just a little higher order ones. They're going to ask you individual function values. You just calculate it, write it out. The last thing they'll do is put variable expressions as the inputs in a function. All right, so let me show what I'm talking about. They're going to say find f of 2a. Okay, so what's going to happen now is you're going to put 2a in place of x. And then your job is to just simplify this. You're going to have an a variable in your answer. Okay, so you're just going to simplify what you have here. So 2a squared is 2a times 2a, which is 4a squared. 3 times 4a squared is, we'll multiply the 3 and the 4 together, get 12a squared minus 5. And that's all the more I can do. So the answer is going to be this expression when you plug 2a into the function. Okay, your answer won't be a single number itself because you have another variable in here. Okay, what if it's a little more complicated? So here's our function, -7 plus 4x over 5 plus x. And they say find f of 5x. All right, so I'm going to replace in the f function both of the x's with 5x. So it's going to look like this, -7 plus 4 times 5x over 5 plus 5x. Okay. Now in the numerator, I got -7 plus 4 times 5x. I can do 4 times 5x, right? That's going to be 20x. The denominator is 5 plus 5x. We can't add these two together. They're not like terms. One's got an x, one doesn't. They're different. Up here, -7 and 20x, they're not like terms. Okay, I can't add these together. We can't do any canceling because you can only cancel when you have products in the numerator denominator. These are sums, so I can't do any canceling. So this is my final answer right here. I just leave it like this. Okay, so your answers won't come down to a number, they'll be an expression when you have variable expressions as inputs. Okay, so that gives you some stuff to look at tonight. You're going to work on function values, whether it be doing it as a graph or a table, or giving you a function rule and having you plug the numbers in and find them. Okay, so the homework is on Alex. Please write out all your work, have that ready, and I'll let you get at it.